Let's start AS level paper 2 of February March 2025, variance 22. The duration of this paper is 1 hour 15 minutes. Before attempting the paper, you need to read the instructions very carefully. The total mark for this paper is 60. All right. Let's start the questions. Phosphorus and chlorine are elements in period 3 of the periodic table. Chlorine forms 3 different compounds with phosphorus. Well, chlorine can form many compounds with phosphorus. The most common compounds are PCl3 and PCl5. बिल्कुल सही बात है. इसको कहते हैं phosphorus trichloride, and this is going to be phosphorus 5 chloride. It is also called phosphorus trichloride. It is also called phosphorus pentachloride. Complete the table. 1.1 PCl3, PCl5, oxidation state of phosphorus. Now for PCl3, in order to calculate the oxidation state of phosphorus, let's suppose phosphorus is X, chlorine found in group 17 of the periodic table, so it has a charge of -1. We have 3 chlorine atoms, so into 3. Since the molecule is neutral and has no charge, which is Y equals to 0, then X equals to +3. So in PCl3, the oxidation state of phosphorus is +3, whereas the oxidation state of chlorine in this compound is -1. See, I have written this here. Let's talk about PCl5. So let's suppose phosphorus is X. Chlorine has a charge of -1. We have 5 chlorine atoms into 5. Since the molecule is neutral and has no charge, which is Y equals to 0, then X equals to +5. So the oxidation state of phosphorus in PCl5 is +5. Over here, the oxidation state of chlorine is -1. ये लिखा हुआ -1. ठीक है? Next, in a closed system, since the reversible reaction, which always takes place in a closed system, PCl3 and PCl5 exist in an equilibrium mixture as shown in reaction 1. You need to be very, very careful because the reactants and products exist in different state, all right? And delta H is negative also, which means reaction is exothermic. And okay, now the question is, deduce 2 conditions that favors the production of PCl5 in reaction 1. According to Lee-Schutter's principle, whenever we have an exothermic reaction, and if we decrease the temperature, equilibrium favors towards right-hand side, and therefore the production of PCl5 increases. So the first condition would be decrease in temperature. Now the second condition, see, I need to ignore liquid and solid. So we need to consider only gaseous substances. So on the reactant side, we have 1 mole of gas. On the product side, we have 0 mole of gas. So if we increase the pressure, then according to Lee-Schutter's principle, equilibrium favors in that direction where we have less number of moles. Since number of moles on the product side is number of moles on the product side is 0. So if we increase the pressure, equilibrium favors towards right hand side, and the production of PCl5 again increases. So decrease in temperature and increase in pressure increases the production of PCl5. That's an easy part. The third compound of phosphorus and chlorine, W, has a relative molecular mass between that of PCl3 and PCl5. The compound contains 69.6% by mass of chlorine. Deduce the molecular formula of W. So first of all, mass of phosphorus so 100 minus 69.6. So 100 minus 69.6 is going to be 30.4. All right. So that is the mass of phosphorus by percentage. All right. Next step, we have phosphorus and we have chlorine. We have two different elements. All right. The percentage by mass of phosphorus is 30.4 and the percentage by mass of chlorine is 69.6. In order to calculate moles, divided by its relative atomic mass, which is 31. So I'll get the moles. And the moles is 0.9806. Divide 35.5. 69.6 divided by 35.5. So I'll get the moles of chlorine, which is 1.9605. Now 0.9 is basically the least amount. To get the simplest ratio, divide this value on both the sides. I mean, from both the elements. So it's going to be 1 divided by 0.9806. It's going to be 1.999. And that means it's going to be 2. All right. So we have one phosphorus and we have two chlorine. So the empirical formula for this compound is PCl2. Molecular mass is not given in the question. So according to my instruction, if molecular mass is not given and examiner is looking for the molecular mass, so just what you can do is just double the empirical formula, you will get the molecular formula. So it's going to be P2Cl4. Okay. W is the liquid at room temperature and pressure. It reacts vigorously with water. That's a very powerful statement. Reacts vigorously with water. And that indicates the bonding exist in this compound would be covalent because it reacts vigorously to form an acidic solution, such as the structure and bonding in W. Obviously, P2Cl4 contain covalent bonding and has a molecular structure or simple molecular structure. Why? Because it can easily hydrolyze with water. अगर ionic compound होता तो it will dissolve, right? Instead of vigorous reaction. Because it is hydrolyzed with water. And also, it is a liquid at room temperature pressure, which means it has a low melting and boiling point. All right. Let's move on to the next page. B part. Figure 1.1 shows a reaction scheme involving P4 and chlorine. So when P4 and chlorine reacting together, converting into PCl5. So when phosphorus react with excess amount of oxygen. So I have given you this instruction in the class. Whenever phosphorus and excess oxygen react together, obviously P4O10 is going to be formed. P4O10 is the oxide of phosphorus existed its highest oxidation state. All right, P4O10 is going to be the product. Agar ye excess nahi hota, so it's going to be P4O6. All right. Now, P4O10, when dissolved in water, obviously it will give you an acidic solution of H3PO4, which is going to be phosphoric acid. Similarly, when PCl5 reacts with water, obviously again B is formed, again phosphoric acid is formed. PCl5, when treated with C, obviously this compound is formed. So C is going to be OH, CH2, CH2, and OH. So C is going to be a diol, because when diol is treated with PCl5, it will substitute both OH through chlorine atom. All right. So PCl5, when treated with diol or ethane 1,2-diol, I'll get this compound due to substitution of OH through chlorine atom. All right. We have done this reaction in our lecture, if you remember. State what is observed in reaction 2. So observation is very simple. Yellowish green color of chlorine will disappear. Predict the shape of the molecule of PCl5. We have done this in class. Its shape is trigonal bipyramidal. So trigonal bipyramidal is the shape. How come? Let me draw the structure. We have 5 chlorine atoms, right? So phosphorus belongs to group 15 of the periodic table, which means it has 5 valence electrons. Let's distribute these 5 valence electrons. You get 4. This one is 5, right? After the distribution of 5 electrons, we have how many single bond around phosphorus atom? 5. There is no lone pair in the valence shell of phosphorus, which is 0. So total is going to be 5. Let me draw 5 lines. The first line is always represented by S, the 3 lines represented by P, and the remaining line is represented by D. So the hybridization is going to be sp3d. So whenever we have sp3d hybridization with 5 single bond and a 0 lone pair, geometry is going to be trigonal pyramidal, and angle is going to be 120 along with 90 degree. If you remember, we have discussed this entire case in the class, right? Write an equation for the formation of A. That's easy. Phosphorus is reacting with oxygen in excess amount, converting into P4O10. All right. So it's going to be 5 here. Reaction 3, P4O10. Now, in the next part of the question, name B, which is formed in both reaction 4 and 5. Name B. B is phosphoric acid. An examiner is looking for the name, which means you cannot write the formula. Remember, examiner is looking for the name. Draw the structure of C used in reaction 6. Obviously, it's going to be the diol, ethane 1,2-diol. This is CH2OH. This is CH2OH, or even we can write in the skeletal structure or skeletal form. This is OH, CH2, CH2, and this is going to be your OH. Either you can write in this way or in the skeletal way, it's totally up to you. But by the way, since examiner has given the skeletal structure here, so my recommendation is that you need to write this structure instead of this. All right. I believe both will be acceptable, but since we don't have any marking scheme, so as per question ki nature, I can give my answer. All right. Oh my goodness, that's part C. 1,2-dichloroethane. 1,2-dichloroethane is basically an alkyl halide. reacts with NaOH, and remember NaOH is basically the nucleophile. To produce an unsaturated compound, unsaturated compounds are those which contain double bond between the carbon atom. And it's not necessary double bond. It could be triple bond or double bond. Both are possible. All right. The triple bond or double bond, both are possible. Now the next question is, what is meant by unsaturated? So that's an easy question. Unsaturated means contain double bond or triple bond between carbon atom. And if you remember, in organic chemistry, double bond and triple bond are collectively called multiple bonds. All right. So you can write even multiple bonds. Unsaturated means contain multiple bonds. That's the only answer. State the condition for reaction 7. So whenever alkyl halide reacts with NaOH, reaction takes place in the presence of ethanol, which will serve as a solvent, obviously. And the condition is going to be obviously heat. Since ethanol is highly flammable, so we need to heat it through water bath. Okay. Compound D contains carbon, hydrogen, and chlorine only. That's a very powerful statement. Only shows the mass spectrum of D. Okay, this is the mass spectrum. These are the fragmentation peaks, or this peak is the base peak because it has 100% abundance. This is, oh my goodness. Okay, there is no instructions given. They have given only carbon, hydrogen, and chlorine information. And oh my goodness, wait. See, this is your molecular INP because it will give you the information about the molecular mass of the compound. So the molecular mass of compound is 60. This is M+1 peak, and this is M+2 peak. So if molecular mass is increased by 1 unit, then it becomes M+1 peak, which is 61. If molecular mass is increased by 2 unit, which is 62, obviously it's going to be M+2 peak. And this is going to be your molecular INP, which indicates the molecular mass of the compound. So I've got one information from this, that compound D has an MR of 60. This is the first piece of information I've collected from this spectrum. I can get second piece of information from this spectrum. Look at this. This is 100% abundance, and this is approximately 33% abundance, right? Yeah, this is 33% abundance. Approximately 33%. So if it is 100%, so if it is 100%, it is 33%. So the ratio between molecular INP and M+2 peak would be 100 ratio 33. That is 3:1. which means compound D contain only one chlorine atom. That's another piece of information I've collected from this spectrum. Compound D contain only one chlorine atom. Okay. Explain the relative abundance of peak 1 and peak 2 in the mass spectrum. This is the relative abundance. Peak 1 has an abundance of 100%. Peak 2 has an abundance of 33%. So ratio between them is 3:1 respectively. Okay. Oh my goodness. Suggest the structure of D. Oh my goodness. I've got only one information in this, that I have only one chlorine atom in this compound. The MR is 60 and compound contain carbon, hydrogen and chlorine only. So, formula कैसे determine करें? Let's apply the trial and error method. MR of this compound is 60. Subtract this value from 60 because this value represents one chlorine atom. Let me calculate. Subtract 60 minus 35 is basically 25. Now 25 contain both carbon and hydrogen atoms, right? How many carbons? How would I know that? (21, 22, 23, 24). We have one peak at 24. And that indicates that we have two carbon atoms. Okay, because peak appear at 24. If this peak appear at 24, that indicates two carbon atoms are present. Because one carbon has a mass of 12, so two carbon has a mass of 24. So subtract 24 from this, that indicates C2, two carbon atoms. So how much left? One, and that represents hydrogen atom. So we have two carbon, one hydrogen, and one chlorine atom. And we need to find out the structure. So what we can do is, let's write two carbon atoms. Let's write one chlorine and one hydrogen atom. So we know that each carbon has three covalent bonds. Sorry, 4 covalent bonds. Wait. Let me start. I think. Let's make 2 carbon atoms here. We know that each carbon forms 4 covalent bonds. So in order to satisfy the number of bonds, let's draw the triple bond here. 1 bond here, 1 bond here. So this carbon has 4 bonds. This carbon has also 4 bonds. Now I need to satisfy one hydrogen atom. Attach hydrogen here, and I need to attach chlorine atom. So यहाँ पर chlorine attach करो. That's your structure. The MR of this compound is going to be 60. First thing. If chlorine is 35, right? What if chlorine is 37? So obviously MR is going to be 62. And that's your M plus 2P, which has already given. One more thing. If I'll do some sort of fragmentation in order to confirm my answer, let's do fragmentation. यहाँ से एक bond break कर दीजिए. Carbon has positive charge. That's triple bond. That's Cl, and that's hydrogen radical. So mass to charge ratio for this is basically how much? 24 plus 35 is basically 59. So obviously if अगर मुझे ये फ्रैगमेंट मिला है 59 के ऊपर, तो इसकी पीक भी 59 पर होनी चाहिए. So ये रही पीक 59 के ऊपर. All right, which means that's my correct answer. That is the correct answer, because this structure gives this peak in the mass spectrum, along with molecular ion peak and M+2 peak also. Okay. Let me get another peak. If I'll break the bond from here, so obviously it's going to be how much? 25. Let me check 25 ki peak hai ya nahi. 21, 22, 23, 24, 25. This is 25 ki peak. My bad. Hold on. My bad. This is 25 ki peak also. ये 25 की peak है. So that indicates कि आपके पास fragment कौन सा होगा? H, C, triple bond, C positive. Because इसका mass to charge ratio 25 है. That's a tricky part. Okay. I hope it makes sense to you. So मुझे 1 मार्क के लिए वर्किंग ये करके देनी है, बट ये वर्किंग कैसे आ रही है, क्यों आ रही है, और इसको मैं कंफर्म कैसे करूंगा एग्जामिनेशन हॉल में, मैंने ये समझाया आपको. ओके. बहरहाल ये इंपॉर्टेंट है, ये एग्जामिनर को जाएगा. Question number 2. All right, the group 2 element shows metallic bonding. Define metallic bonding. We have 2 marks for this part. It is an electrostatic attraction between positively charged ion and C of delocalized electrons, also called mobile electrons. Next, the group 2 elements forms stable 2 plus cations. State and explain the variation in the ionic radius of the group 2 elements down the group. That's an easy thing. Down the group, number of shells increases. Shielding increases. Nucleus to valence electron attraction decreases. Hence, ionic radius increases down the group. Table 2.1 shows successive ionization energy values for beryllium. Use table 2.1 to state and explain the general trend in these values, the significance of the large difference between second and third ionization energy. So technically, successive ionization energy values always increases. Always increases because of less shielding effect. See ना, जैसे जैसे number of electrons remove होंगे, shielding effect कम होना शुरू हो जाएगा. Because of less shielding effect and smaller ionic radii. Okay. Now, second and third has a massive jump that indicates there is a change in shell between these two, which means this third electron comes from the inner shell, right? Biggest jump exists between second and third, which indicates that the third electron is coming from the inner shell. So first electron is removed from the outermost shell. Second electron is removed again from the outermost shell. This third electron removed from the inner shell, right? Fourth electron is removed from the inner shell again. So electron हमेशा सबसे पहले outermost shell से remove होता है, which is why these two electrons are removed from the outermost shell. This electron is removed from the inner shell or the middlemost shell, you can say. All right. What is the configuration of beryllium? 1s2, 2s2. Atomic number is 4. Now these two electrons are removed from the 2s orbital, and this electron is removed from the 1s orbital. And this 1s orbital is basically the inner shell. All right. I hope it makes sense to you. Part C. All the group 2 elements except beryllium have more than one stable isotope. Beryllium exists as a single isotope, Be49. Describe the distribution of mass within an atom of beryllium. First of all, let me check the atomic number and the mass number. So we have 4 protons here and 5 neutrons here. All right. And both these heaviest particles are found in the nucleus. While 4 electrons have the lowest mass, so they will exist in orbitals around the nucleus. Next part, complete table 2.2 to show the numbers of proton and neutron in the isotopes of magnesium. Magnesium has an atomic number of 24 and its isotope is magnesium 24. The number of proton is 24. Number of proton is again 24. Number of proton is 24. You know, in isotopes, we have same proton number and electron number. We have same proton electron, but different number of neutrons. So obviously number of proton in each isotope would be same. Oh, my bad. My bad. What's the silliest mistake I've done? The atomic number of magnesium is 12, which means it has 12 protons. All right. You have to be very, very careful. अगर मुझसे गलती हो सकती है तो आप लोगों को भी बहुत एहतियात रखनी होगी. Number of neutrons, 24 minus 12 is going to be 12. 25 minus 12 is going to be 13. 26 minus 12 is going to be 14. So my concept was right because isotopes have same proton number but different number of neutrons. So number of protons same, number of neutrons are different. Anyway, let's move on the next part. Figure 2.1 shows the behavior of the beam of the particles in an electric field. Complete table 2.1 to show the behavior of the separate beams of neutrons, electrons in the same electric field. Label your diagram clearly. Assume that the beams of each particle are moving at the same velocity. So first of all, let me mark the reference line. Let me mark the reference line here. This is the reference line. Since protons are deflected towards this plate, which means this plate is going to be negatively charged because protons are positively charged particle, which is why they will deflect towards negative plate. And consequently, this plate is going to be the positively charged. If this plate is going to be the positively charged, obviously electrons are deflected towards positive plate. Okay. It's not right because accurate. No. Let me draw the accurate. Much better. So this is beam of electron. How about the neutrons? Neutrons are neutral. They will not deflect, which means this is not the reference line. This is the beam of neutron. So neutrons are neutral. They will not show any sort of reflection between these two charge plates. Protons are positively charged. They will deflect towards negative plate. Electrons are negatively charged, so they will deflect towards positive plate. Okay. And obviously, proton has a smaller angle of deflection, whereas electron has a greater angle of deflection. And we have discussed such issues in the class. Hope you remember that. D part. State what is observed when dilute hydrochloric acid is added to separate sample of barium oxide and barium carbonate. First of all, examiner is looking for the observation. और आप जानते हैं कि barium oxide is basically a solid at RTP. So when you put dilute hydrochloric acid in it, obviously ये barium oxide है आपका, आप इसको हाइड्रोक्लोरिक एसिड से रिएक्शन करवा रहे हैं. So it will turn to barium chloride, which is a soluble salt. इसका colorless solution होगा. Water बनेगा, इसका भी colorless solution होगा. HCl का भी colorless solution होता है. तो obviously ये जो barium oxide का white solid है, ये disappear हो जाएगा. White solid will disappear. All right. Now, barium carbonate is BaCO3. When you add hydrochloric acid in it, there is a reaction takes place, and obviously you will get barium chloride, which is soluble salt. It will give you an aqueous solution, water, again colorless solution, and carbon dioxide. So technically, effervescence of carbon dioxide gas is given off, and this white solid dissolved, right? So solid dissolve, and brisk effervescence is given off. Brisk effervescence term is fixed for carbon dioxide. Now write an equation for the reaction of strontium with an excess of cold water. That's easy. We have done this in class. The strontium, when react with the excess amount of cold water, will get strontium hydroxide and hydrogen gas. Obviously, is hydrogen gas ke bubbles honge, and since the reactivity down the group increases, so bubbles of gas given off rapidly. All right. State the variation in the solubility of group 2 sulfates down the groups. Down the group, solubility of group 2 sulfates decreases. Solubility of group 2 sulfates decreases. All right. So that's the end of this question. Let's move on to the question number 3. Seems it is related to group 17. Halogen, chlorine, bromine, and iodine shows trend in chemical and physical properties down the group. Shows some properties of chlorine, bromine, and iodine. All right, complete the table 3.1. What's not given? Bromine ka color at RTP and iodine ka color at RTP. So bromine is a brown liquid. और रेड ब्राउन भी कह सकते हैं आप. Iodine is a black solid. All right. So chlorine के लिए क्या है? Okay. Chlorine has a bond energy of 242, 193, and 151, which means bond energy from chlorine to iodine decreases. And we have discussed this issue in the class, in the lecture, right? Electron negativity also decreases. So there are two trends, electron negativity trend and bond energy trend. Let's talk about the next part. The bond energy values refer to XX bond, where X is the halogen. Explain the trend in the bond strength of the XX bond in halogens. That's very easy. Down the group. Atomic size of halogen increases. This increases the bond length. And weaker the covalent bond. All right. Thus, down the group, thus bond strength decreases. Explain with the use of an equation how chlorine is used in water purification. State the role of the active species product. That's easy. We have discussed this in states of matter. If you remember, water and chlorine are reacting together disproportionately, converting into HCl and chloric 1 acid, which is a formula of HClO. This HClO is an oxidizing agent, if you remember. And this oxidizing agent is used to kill bacteria and microbes. Also, this reaction is called disproportionation reaction. The sodium halides in table 3.1 also shows trends in chemical properties. Identify the sodium halide that reacts with concentrated H2SO4 to form H2S gas. Oh, H2S gas is obtained whenever sodium iodide is treated with concentrated H2SO4. So I have to make that equation, and we have done that in class. So it's basically identify the sodium halide. So that sodium halide is going to be sodium iodide, because sodium iodide gives hydrogen sulfide gas. Identify the sodium halide that only undergoes a bronzed-lowry acid-base reaction with concentrated H2SO4. That's sodium chloride. Because concentrated sulfuric acid cannot oxidize chloride into chlorine. It will turn into misty fumes of HCl, if you remember. All right. That's what we have done in the class. This is NaCl. This is concentrated H2SO4. Instead of making chlorine, it's going to make misty fumes of HCl, which means in this reaction, concentrated H2SO4 is acting as an acid. So it undergoes bronzed-lowry acid-base reaction. And sodium sulfate. A student adds a few drops of silver nitrate to a solution of NaBr. State what is observed. Whenever silver nitrate and NaBr reacting together, converting into creamy precipitates of silver bromide and a colorless solution of NaNO3, because all nitrates are soluble. So creamy precipitates. All right. Next, iodine monochloride. Oh, sorry, iodine monobromide is a dark red solid. It is a solid, first of all. Second thing, iodine monobromide is basically an interhalogen molecule. We have discussed this in class, if you remember. All right. IBr reacts with propene. By the way, this is unsymmetrical reagent. By the way, this is unsymmetrical alkene. So whenever they will react together, obviously, they are gonna follow Markovnikov rule. And when we follow Markovnikov rule, obviously we'll get two different sort of products. The first one is major and the second one is minor. Obviously, जो major product है वो Markovnikov rule के through बनेगी, जो minor product है वो Markovnikov rule को follow नहीं कर रही हो, उसके through बनेगी, right? The mechanism for this reaction is same as the mechanism for that of HBr and propene. See, I've told you about that. Identify all the intermolecular forces that exist between molecules of IBr. If you have any covalent molecule in the world, any simple covalent molecule in the world, Instantaneous dipole. Instantaneous dipole, induced dipole forces, जिसको हमने चैप्टर पढ़ते हुए आईडी फोर्सेस का नाम दिया था. And both of them have different electron negativity values, which means both, and due to polar polarity or polar nature, exhibit permanent dipole forces. Permanent dipole forces. Name the mechanism involved in the reaction of IBr and propene. Propene is an alkene, and all alkenes undergoes electrophilic addition reaction. So my answer would be electrophilic addition reaction. Okay, the next part is the reaction of IBr with bromine forms two structural isomers. Draw the two structural isomers shown by these molecules. Let me give you a slight hint for this structure, for this reaction. This is propene. And this is your iodine monobromide. Since iodine has a less electron negativity, so it has a slight positive charge. Bromine is more electronegative element, so it has a slight negative charge. All right. Now I'll get two different products. The first one is minor product, which never follow Markovnikov rule. So basically, this is your electrophile. And this is going to be your nucleophile in the reaction. So if you remember, Markovnikov rule क्या कहता है? In an unsymmetrical alkene, the positive part of unsymmetrical reagent goes to that double bonded carbon atom where we can have more hydrogen atoms, which means ये जो iodine है ये इस CH2 के साथ attach होगा, ये bromine इस CH के साथ attach होगा according to Markovnikov rule. So this CH, Br, and CH2I. This is your major product. Obviously 90% होगी है, और you can say 95%. और minor product जो है वो Markovnikov rule को follow नहीं करेगी. Never gonna follow Markovnikov rule. And in that, iodine has to be here and bromine has to be here. So this is going to be your minor product. It could be 10% or 5%. All right. So both of them are isomers of each other. All right. Because both of them have the same molecular formula but different structural formula. All right. So let me draw these two structures. This is CH3. This is CH. This is Br. This is CH2. This is I. This is CH3, CH, I, CH2Br. You can write these structure in skeletal structures also, all right? Skeletal structure, in terms of skeletal structure, how can we write these structures? CH3, CHBr, this is CH2, and this is I. CH3, CHI, this is CH2, and this is Br. All right, I hope it makes sense to you. Identify the types of structural isomerism shown by these molecules in D3. Since the position of functional group is changing, which means both of them are positional isomers of each other. Explain why the two structural isomers do not form in equal amount. Let's go back to this stage. We have discussed all these issues in class. दोबारा से कर लेते हैं आज. Now let me shift this pi bond onto this carbon atom. So as a result of shifting of pi bond onto the carbon atom, it becomes electron rich, so carries negative charge. CH2 carbon becomes electron deficient, so it carries positive charge. And obviously, whenever carbon has positive charge with two hydrogen atoms, is going to be 1 degree carbocation. All right. Another possibility of shifting pi bond could be like this. ये pi bond is CH2 के ऊपर shift होगा. So when pi bond shifts on the on CH2 carbon, obviously that carbon becomes electron rich and carries negative charge. This carbon becomes electron rich, electron deficient, carries positive charge. So this carbon is 2 degree carbocation, and 2 degree is basically more stable than 1 degree carbocation. That's what we have discussed, right? So 2 degree is more stable than 1 degree. So reaction किसको follow करेगा? Reaction obviously 2 degree carbocation के route को follow करेगा, and from that route I'll get the major product, and from 1 degree carbocation के route I'll get the minor product. 2 degree carbocations follows the Markovnikov rule. 1 degree carbocation की product follows anti-Markovnikov rule. So this is your primary carbocation, this is your secondary carbocation, which is why both the products are not in equal amount. Reaction follows 2 degree carbocation then 1 degree, because 2 degree carbocation is more stable due to the positive inductive effect. Of electron donating alkyl group. All right. And how come positive inductive effect? So एक आप नोट करें, ये पॉजिटिव इंडक्टिव इफेक्ट है और दूसरा ये है, जबकि यहाँ पर सिर्फ एक ही है पॉजिटिव इंडक्टिव इफेक्ट. ऑलराइट, सो इसकी स्टेबिलिटी ज्यादा है, इसकी स्टेबिलिटी कम है. ऑलराइट, I hope it makes sense to you. That's the end of this question. Let's move on to the next page. That is question number 4. Figure 4.1 shows compounds J to M, each of which contain 4 carbon atoms. Okay. This is basically an aldehyde. This is basically ketone. This is secondary alcohol, and this is carboxylic acid. Table 4.1 gives details of test J to M. In each test, only 2 compounds give a positive result. Complete table 4.1. Potassium dichromate 6 can oxidize aldehyde and secondary alcohol. Ketone and carboxylic acid never gonna oxidize. So it's J and L. ओ तो आपसे ऑब्जर्वेशन मांग रहे हैं. So orange to green. All right, because K2Cr2O7 is orange. Whenever it undergoes a chemical reaction, obviously green color is observed. Compound that gives a positive test J and L. Okay, ये examiner ने खुद बताया हुआ था. Okay, fine. Alkaline aqueous iodine उस वक्त पॉजिटिव टेस्ट देगा जब उसके पास CH3 CHOH एक साथ होगा. सो आप नोट कीजिए कि ये CH3 CHOH एक साथ लिखा हुआ है, इसका मतलब आइडोफॉर्म का टेस्ट यहाँ पर भी पॉजिटिव आएगा. CH3CO ग्रुप भी एक साथ लिखा हुआ है, इसका मतलब आइडोफॉर्म का टेस्ट इसमें भी आएगा. तो ये भी CH3CO ग्रुप गिवन है और यहाँ पर CH3 CHOH ग्रुप गिवन है, इसका मतलब दोनों में पॉजिटिव टेस्ट आएगा. तो जब पॉजिटिव टेस्ट आएगा येलो प्रेसिपिटेट्स अपीयर होंगे, एंटीसेप्टिक स्मेल होगी, KNL आप मेंशन करेंगे यहाँ. Now orange precipitate aldehyde के साथ आते हैं. अगर हम उसको 2,4-DNPH से रिएक्शन करवा लें, टू फोर डाई नाइट्रो फिनाइल हाइड्रोजीन. So जाहिर सी बात है 2,4-DNPH का जो टेस्ट है, this test is positive both for aldehyde and for ketone. That means J and K both give positive test. Sodium can react with alcohol and carboxylic acid only. So bubbles of gas is given off. And obviously L and M. Okay. Next, K reacts with hydrogen cyanide in the presence of potassium cyanide catalyst, forming N. This K is going to be either aldehyde or ketone. So this is basically ketone. Okay. Complete figure 4.2 shows the mechanism of this reaction. Include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. So this is basically your lone pair. This is basically your slight negative. Carbon is slight positive charge. Reacting with this, shifting pi bond towards the oxygen atom. So the intermediate acts like this. This is C2H5 will remain as it is. और ये cyanide attach हो जाएगा. Okay. Now we have hydrogen ion. This negatively charged oxygen reacts with hydrogen ion, converting into OH. Okay, rest of the molecule will remain as it is. So कोई changes नहीं आ रही. This entire thing will remain as it is. Only changes takes place on this species. Oxygen being a negative charge except proton and converting into OH minus. I hope it makes sense to you. And that's what we have done in the class, because that's nucleophilic addition reaction to mechanism. Identify the class of compound of which N is a member. Whenever OH and cyanide is attached to the same carbon, then it is called cyanohydrin. Let me write the structure properly. CH3, ClOH, This is CN, this is CH2, this is CH3. So I can say that this is hydroxynitrile. ये भी कह सकता हूँ. But I think hydroxynitrile is not an appropriate name for this compound. And instead, cyanohydrin is much better. All right, because cyanohydrin is a general term which is applicable for all compounds and has a chiral center. Obviously, it has a chiral center. This is the chiral center because this is going to be the first group, second group, third group, and this one is fourth group. And has a chiral center. Explain what is mean by the chiral center. When 4 different groups are attached to carbon atom, then it is called chiral carbon. I think that's the end of this paper because constants की values are, yeah, that's the end of this paper, guys. I hope it makes sense to you. Thank you.